Hello and welcome to the trigonometry review for our test that is going to take place on Thursday. In this video, I'm going to do several examples, and then throughout the video, Edpuzzle will have you practice one of your own. Let's get started. So we're going to start with the Pythagorean theorem. When you have a right triangle signified by the little square in the corner of the triangle, you can use the Pythagorean theorem to find a missing side when you know two of the sides. In order to use the Pythagorean theorem, you have to understand the parts of the right triangle. The two segments that form the right angle are called the legs. The side across from the right angle is called the hypotenuse. There are two ways to use the Pythagorean theorem. When you're missing the hypotenuse, you are going to use the Pythagorean theorem a squared plus b squared equals c squared. That is the example we have here. This example gives us legs of 6 and 2 and asks us to find the hypotenuse c. In order to do this, it's a two-step process. We're first going to plug in our leg values for a and b. We get 6 squared plus 2 squared. When I do 6 squared plus 2 squared, I get 40. The second step is to take the square root of the answer that you got, so the square root of 40. When I take the square root of 40, I get 6.3 as an answer. So that is the missing hypotenuse. Here, you try one. Let's try another example. In this example, I have a right triangle, and I'm asked to find a missing side when I know two of the sides. This is a Pythagorean theorem example. I'm quickly going to identify what I have, 2 legs and a hypotenuse. And I see that I'm missing a leg. When I'm missing a leg, I have to use the subtraction method of the Pythagorean theorem. So in this case, a squared equals c squared minus b squared. Again, it's a two-step process. First, I'm going to take my hypotenuse and I'm going to square it and subtract it from the leg that I know, squared. 9 squared minus 4 squared is going to be 65. The second step in this process is to take the answer that you got and take the square root. The square root of 65 is 8.1, and that is the missing side. Here, you try one. Let's take a look at another example. In this case, I have a right triangle, but I only know one of the sides. However, because I know one of the angles, I can use trigonometry to find a missing side. The first thing you have to do is you have to identify what you know about the triangle. We call this the reference angle because it's the one that's given to us in the problem. From my reference angle, I can identify the hypotenuse because it's opposite the right angle. The side across from the reference angle is called the opposite side. And the side next to the reference angle is called the adjacent side. We learned in class that there were 3 trigonometric ratios that we were going to use. The first one is called sine. The next one is called cosine. And the third one is called tangent. Each one of these has a particular ratio. Sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. Based upon what I know about this problem, I'm trying to find the side PR. PR is opposite my reference angle. I know one of the legs is 3.2. That is the adjacent side. Opposite over adjacent is equal to tangent. So if we use the tangent function, so tangent of my reference angle, 57, over 1 is equal to x over 3.2. When I cross multiply, I get 3.2 tangent 57. Putting that in my calculator, I get 4.92 or 4.9. And we've found the missing side. Here, you try one. Let's try another example. In this example, I'm asked to find an angle, and I'm given a right triangle with two sides. If you are looking to find an angle and you have some side information, you can use inverse trigonometry to find that angle. The same ratios apply, just in the opposite order. First we have sine, then we have cosine, and then tangent. Sine is once again equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And tangent is equal to opposite over adjacent. Let's take a look at our example. We're trying to find angle x, so angle x becomes our reference angle. Based upon where I'm located, I know that 8.2 is the hypotenuse, WV is opposite, and 7.3 is adjacent. I'm trying to find angle x, and I know adjacent and I know hypotenuse. Adjacent over hypotenuse is equal to cosine. But since we're trying to find an angle, I'm going to use inverse cosine. So inverse cosine. Keep in mind that it's adjacent over opposite, so it's going to be 7.3 over 8.2. Once I put this into my calculator, I get 27.1 degrees. That is the measure of angle x. Here, you try one. Let's look at another example here. In this example, I'm asked to solve the right triangle. When I'm asked to solve the right triangle, that means that they want to know all the missing sides and all the missing angles. What I like to do is I like to record what I'm missing and then work on them one at a time. So for example, I know that I'm missing angle B in this problem, so I should put it on my list of things to find. I also can see that I'm missing side BC, so I'll put that on the list of things to find. And finally, I can see that I'm missing side CA. And we'll do that in red. Let's start with the missing angle. So in this case, because it's a right triangle, I can subtract angle A from 90 to get angle B. This works because angles of a triangle add up to 180 degrees, and the 90-degree angle takes up half of that. So if I take 90 and I subtract 42, I get 48 degrees. So one of my problems has been solved. Now let's take a look at one of the sides. Let's take a look at BC. If I make 42 my reference angle, BC would be opposite, 9 would be hypotenuse, and AC would be adjacent. Based on this information, I can see that I'm trying to find opposite, and I know the hypotenuse. That's going to be the sine ratio. So the sine of 42 over 1 is equal to x over 9. Using cross multiplication, I can see that 9 sine of 42 will get me my answer. I plug 9 sine of 42 into the calculator, and I get 6.02, or 6. Let's find our third side. Once again, from angle 42, I can see that CA is the adjacent side, and I know the hypotenuse. In this case, I'm going to use the cosine of 42. It's still going to be equal to x over 9. And when I cross multiply, I'm going to get 9 cosine of 42. Putting that into my calculator, I am going to get 6.68, which would be 6.7. All three sides have been found. Here, you try one. Let's take a look at one last example. Here, I'm asked to solve the right triangle again. So first, let's identify what the parts we are missing. I know I'm missing angle T. I can also see I'm missing angle S. And lastly, I can see that I'm missing side TR. Let's start with the missing side, TR. Because I know two sides of the right triangle, I can use the Pythagorean theorem to find the missing side. Because the side that's missing is a leg, the subtraction method of the Pythagorean theorem is the one I'm going to use. So step one is to subtract the hypotenuse squared from the side that I know squared. When I do 6 squared minus 4.6 squared, I get 14.84. The second step in the process is to take the square root of the answer, and the square root of 14.84 is 3.9. So I know that my missing side is going to be 3.9. Now looking at the angles, if we start with angle T, I know from angle T that 4.6 is the opposite side, and 6 is the hypotenuse. Opposite over hypotenuse is going to be sine, and because we're looking for the angle, we're going to use inverse sine. So inverse sine of 4.6 over 6. When I plug that into the calculator, I get 50.1. Lastly, I know that the other angle is going to be angle T subtracted from 90. So if I take 90 and I subtract 50.1, 90 minus 50 is going to be 40. 40 minus 0.1 is 39.9. And I have found my third side. Here, you try one. Okay, thanks for practicing and reviewing with us today. If you find you have any questions before the test, just send me an email and I'll reply back with some feedback. Thanks.